Hello everyone. In this lecture we are going to talk about file input output, which means reading and writing from and to some types of files with MATLAB. And the types of files we are going to look at are binary files, text files, and Excel files. So one of the type of binary files we are going to talk about are .mat files, the native MATLAB data files, which are binary. And you know that if you create some variables, I mentioned that in the past, so I briefly just discuss it again. If you create some variables in the workspace, right, and if you want to keep the values of these variables in a binary file .mat so that you can use it later, and if the workspace is cleaned out, then these data are saved somewhere, then you can simply use the command save, and this will save all of the variables in the workspace to a mat file by the default name matlab.mat. So if you do that, you see, all of this data is saved to a mat file called MATLAB, and this .mat file is a binary file. It's not like you can open it simply with text editor and then look at the values in it. Okay, it's not possible. If you can open it with a text editor, if it's possible, then it's not something that you can recognize any values in it. Okay, so you see clearly it's not something you can easily even open. And if you do, it's coded in a way that you cannot do anything with it. So that's about this part. Now, if you don't want to save it to something called matlab.mat, you can provide data and say, hey, save it for me to maybe my data.mat. Then all of the workspace will be saved to a mat file called my data.mat. And now if I clean up the workspace, I can load this file back. By loading this file, all of the data will reappear. Okay, so that's a way to preserve the data in the workspace, save and load. And they have the option that if you don't want to save all of the data in the workspace, only a sub portion of it, you can still do that. So here, let's say when I want to save my data, I say, hey, save it to something like my data1.mat, but the variable I want to store is X and Y. I'm not interested in Z in this case. Okay, and there is some problem here. Probably you have to go with this. Yes, so when you put the name of the file inside parentheses with the command save, not just with the space separated, you have to provide the name as string. And now you see I have my data1.mat, and if I clean up the workspace again, and this time I load this my data1.mat, it should not bring back X, Y, and Z, only X and Y, because that's what we save to that. And similarly, if you saved everything to this mat file my data, when you want to do loading, right, something like this, let me clean it again, you can choose which variables to load. So here, when you're trying to load this my data, which has all three variables in it, you can say, hey, load, but not everything, just load X and Y, and it does. Okay, so you can be selective about what to save, what to load to MATLAB binary files called .mat files. That's about save and load. Now, there are other types of binary files that MATLAB can create for you, read and write from. They are not necessarily .mat, and they might even be like a text file. right? You can write a text file with MATLAB, open, write, read, and so on. But the way that MATLAB writes the data to this text file is in a binary format. So it's not something like this that you type yourself. So here is a regular text file I created myself, and I'll show you how to read the data from it, okay, using textread. But the type of text file that here I'm going to create for you using the command fwrite, this type of data is going to be written in binary format. It's going to be encoded. So let me show you what I mean by that. So here there are several commands that I want you to learn. One of them is the command fopen. What does fopen do? Well, what fopen does is it opens a file for you with some name, and you open it with some kind of permission. You either open it to read something from it, or write something to it, or do writing as appended, or anything like that. So here we have a file name and something called the permission. And what is this permission? Let me talk about this fast. So the permission is this. If you say W, W means whatever is in the file at the moment, delete them and open it for writing. So whatever you write now is going to be basically replacing the current content. So it's overwriting, basically, writing over the previous data and deleting that. If you say, on the other hand, A means open it for writing, but you're not going to delete the existing content. You're going to append whatever you want to write at the end of the file. So that's the difference between A and W. A will preserve the current content, W will delete it. You also have R. R means reading only. So when you open a file for reading, you are not able to write anything to it. You can just read the data from it, okay? And if you add these pluses, then it gives you more capabilities. So if you say R plus, then you can read and write. The same thing for W plus, right? It can open for reading and writing, and A plus. So, but the ones that we use most of the time are R, W, and A. These are called the types of permissions mostly we use. And here you see, I want to create a file, or you give me a name, I open the file for writing. This command also returns two things to me. One is FID, which is the ID number for the file that I'm trying to open or create and open, and a message. So depending on whether you can open a file or not, MATLAB returns an ID to you. If the ID is positive, bigger than 0, so it could be any number, 1, 2, 5, whatever, an integer number. If this FID is an integer number that is positive, it means the opening was successful. If this FID is not positive, then it means what? The opening was not successful. And you might say, how can the opening not be successful? Well, one reason is the file is already open in some other editor and you cannot open it. Or there is a lock or password, the file is password protected and you cannot open it. So it's not like you can open any file that you want. And again, the file ID is a positive number, and as this description says, it's typically an integer equal or greater than 3. Okay? For a typical file. 0, 1, and 2 are for standard input, standard output, respectively. okay, like the screen and so on. So typically, if it's in just an existing file, the number is 3, 4, 5, and so on. And if you cannot open it, then the ID that it returns is negative. So negative means what? You could not open it. That's why here you see it checks whether it's positive or not. If it's positive means you could open the file or one of the locations that you want to write to and you can do it. If it's negative means you cannot do it. So it says if FID is positive, if you can write, then how can you write now? Now there is the new command fwrite. Now I want to write. So you see with open, I opened it for writing. Now with fwrite, I'm trying to write. What can I write? Write to the file with ID fid some array or whatever data that I have, and you provide the format of writing. Write it with a float 64, which means they are decimal and there is 64 bits allocate 64 bytes allocated to that variable of memory. So here you're providing the precision and the amount of memory to write each one of the data in this variable. And if you look here, what I pass to the fwrite is not the name of the file, it's the ID of the file that you got from fopen. So you cannot directly pass the name of the file to fwrite. You have to pass the ID that you got from fopen. And it returns one thing for you, that is count. And count is the number of data that you could successfully write to that file. So for example, if this array has 1,000 data in it, could you write all of those 1,000 data to that file? If you could, then count is going to be 1,000. If you could only write 200 out of 1,000 data to this file, then count will be 200. Okay, so it's the number of data you could successfully write. And most of the time it is actually the size of this array, but sometimes there might be some memory limitations and not be able to write the whole thing. Right? So that's how fwrite works and that's how fopen works. Now, as I said, fopen, if the opening is successful, it returns a positive ID and there is no problem. If it cannot open, which means this FID is negative, then it returns to you an error message. And here you say, if there is an error message, go ahead and display it. So you might say, what if the opening was successful? What is going to be stored in this message? Nothing. The message is going to be empty. Okay, so if the opening is successful, message is empty. If it's not successful, FID is negative, then this guy is going to be a text that MATLAB has generated for you, and you can display it. Right? So this is opening, this is writing. Good. Now that I opened and I have written, if I don't have anything else to do, now what should I do? I should close the file. Using which command? fclose. And again, to fclose, I'm not going to pass the name of the file. I'm going to pass what? The ID of the file. So I pass the ID of the file and say, hey, close that for me. And then it returns a status, which is either successful or not successful. Okay? And you can check that again. So it returns some output for you. Status, and this status is 0 when the closing is successful. If it cannot close, it's -1. So again, you can check whether the closing was successful or not. If this status return is 0, it was okay. If it was -1, it could not close the file. So here I'm learning some important lessons. First of all, whenever you open something, a file for reading, writing, whatever, and you do whatever you wanted, now before you do anything else, you have to close it. Okay, it's like a door that you have to open and then you have to close. You never leave it open and go. okay, like the door of the fridge. You open it, you get something out of the fridge. Now, before you do anything else, you close the door. Don't leave it open. That's the same thing for the files, okay? For the binary files. You never leave them open, you close them. So that's fopen, fclose, fwrite. Now, sometimes you want to read something from the file, not write something. So what would you do? You open the file, but this time you open it for reading. Again, you have an ID and a message. Let's say the ID is positive and the message is empty, which means it was successful. Now I can read from the file ID some data. What data can I read? So here I pass the ID of the file to fread to read something for me. Then I say, in what format read the data? Here I'm saying read the data for me as a matrix that is 100 by 100. So I'm passing the dimension of the data that is read. And what is the number of bytes for the data? What is the format? It's float 64. So whatever is in that file ID, read it as a 100 by 100 matrix and return to me here two things. One is the result of that reading, that 100 by 100 matrix, store it in this variable, and also tell me how many values you could really read. I'm asking you here to read 10,000 data. Could you really read all those 10,000 data? If you could, you might be able to show me also whether you were successful in reading all of it or not. And then when my reading is done, again, what? Go ahead and close the file. Okay, so all this example that I'm showing you doing is, first, it is asking you to what? To provide the name of a file. And it reads it as string, so even if you don't provide that name inside quotation mark, it already considers it to be a string and it adds the quotation marks to it. And then it generates 10,000 random data and then saves this 10,000 random data to that file. Open it for writing and then write it to that file. So how does it write it? As 1 by 10,000. So the way you write that 10,000 data is as a single array with 1 rows and 10,000 columns. 1 by 10,000, that's the format you write the data into that file. Now you might say, well, this name I provide here to the input command, the name of the file I provide, maybe that file does not exist in the current directory. What does MATLAB do? If that file does not exist, well, no worries, MATLAB will create that for you. So in the fopen, if this file name does not exist, MATLAB will create one for you, especially when you want to write something. So look here. It says, what's the name? And I deliberately create some name here that I don't have, like test3. And I say, hey, write it to test3. And it says, fine. I'm going to write 10,000 values of random numbers to it. And the message was, if you look at the message here, the message was empty, which means the operation was successful, and FID was a number 3 or bigger than 3 positive, so operation was successful. When I'm done writing that 1 by 10,000 data, I'm gonna close the file. Then I try to read back that 10,000 data, but first I open it, then I read it, but this time I read it as what? 100 by 100 data. And then I close it again. So this input array is going to be 100 by 100, while this output array is going to be what? 1 by 10,000, and you can clearly see them in the workspace. Yes, so this is reading and writing to a binary file. And now why do I call it binary file? Because you clearly see the extension of this file is not .txt or anything, okay? And if I try to open it with a text editor, I cannot see anything meaningful in it. It's all encoded binary. You see here? It's not something I can read. And you might say, well, maybe because you did not name it with .txt. If when you were running this example, you said test3 or test4 maybe this time, .txt, now it will create a text file and you are able to what? You are able to open it and see the content of it. Well, here we do it, right? And this time I have test4 and it is a text file, but look. Again, it has something similar encoded in binary. It's not like a regular text file you make from scratch and you can read the content of it. Okay, so it is written as binary format. Okay, good. So fwrite, fread, fopen, fclose. These are four important commands for dealing with binaries. I also told you about load and save. Now let's talk about dealing with text files. Directly text files, not in binary format. How can you read, how can you write to these text files? So if you have a text file, one of the ways that you can read the data from text file, whether it's .text or .dat, is using the command textread. So for this command textread, you provide the name of the file to read the data from. So here I'm going to read these two columns in this file test2.txt. The first column are the names, the second column are the grades. Okay? So my file is going to be test2.txt. And now, what data do I want to read? Here you provide the format and how many columns you want to read. So if you remember, I had two columns. So I have to provide the format to read these two columns. The first column is strings. So I say %s, which means read them as strings because they were names. The second columns were what? Integer numbers for the grades. They were not even decimal, so I can say %d. Or if they are floating, I can say %f. Okay? So for each column, you provide the corresponding format for reading them. And then the result of this is going to be what? A vector where you provide the name of the columns to read from. So maybe you say names and then what? Grades. So read the first column as a string, save it to names. Read the second column as floating, save it to what? Grades. All of them from this text file. And look, here we go. The grades are all here and the names are read as a cell. Why? Because they are different. They are characters or strings with different length, so the only way to read them is read them as a cell. They're all a string, but you have to read them as a cell. And grades are simply a vector. So this is to read data from text file using the command textread. That's not the only command to do, and even in new versions of MATLAB tries to say, hey, don't use this anymore. I don't like it, use something new. Okay, and you can see that here. It says textread is not recommended anymore, use text scan. And if you want, you can do text scan, no problem. Text scan also acts basically quite similar. So if you want, you can do the text scan, no problem. Okay. And that acts quite similar and reads the data in a kind of similar fashion. So if you go down, you can see some more relevant commands, which I mentioned some of them for you. Fopen, right? Fread, fclose, fwrite, load, save. You can read the whole matrix if you want, which is creating an array by reading column-oriented data from a file. So this read matrix can actually be quite similar to that method that we wrote. Now you might say, well, can I apply this read matrix here? So instead of saying this text read, can I say read matrix and give it to some variable called data? Can I read all of it, both columns, from this text file and save it to data? Let's find out. Look at that. No, right? See, clearly it is not doing its job. Why? Because the first column of it is string, the second column are numbers. So here it is going to give you a bunch of nonsense and then nands. Okay, so this is good when all of the data you are reading from that text file are numbers. When it's a mix, this read matrix is not the way to go about it. Okay, so I'm trying to tell you which commands you better or not better use. Okay, so that was about read matrix, not a good idea. There is something similar called read table. Now, when you go read table, again, you can read column-wise from a file, and the file could be .csv, .dat, .txt, Excel, and so on and so forth, right? Now, the thing is, what about here? Can I do something similar to that? Well, let's try that. So here, instead of this read matrix, I say read table and assign it to this variable data, or maybe data 1. And you see, it is doing something, but it only read actually the last 2 people, right? Because if you go back and check, I have 4 rows, 4 people. So it only read the last 2. It did not really read all of it to this data. Okay, so read table, although it looks like it is capable of reading heterogeneous data, but you have to pay attention to the way that it is working, okay, and the way that the data is written. So if you look here, basically what I have is the data separated by comma and not by tabs. You see here the data in this text file that I wrote, they are separated by tabs. Now you might say, what if I separate them just by a comma? Is that going to make any difference? So let's save that and go back and try it again. And yes, you see now it does make a difference. Now it read the whole thing. Okay, so those tabs should not exist in the text file if you want to read columns using the command read table. Okay, that is not going to let you work. But the text read did not care. Even when they were separated by tabs, it would work. Now you might wonder, now that I removed the tabs, does the command text read still work? Let's try that. Now it doesn't. You see, now it's messed up. Now it combined them together. For the names and for grades gave you a bunch of zeros. So you see the limitations. If you do text read, the columns in the Excel file should be separated by a space or tab. If you do read table, the columns should be separated by what? By comma. So now what if I add just a simple space? not tab. One single space. Does it make the text read work? Yes. But if I separate them by comma, different columns, it's not going to work. You need space or tabs, while for a read table, you need commas. Okay, so these are important things to know how to work with these different commands. Now, we looked at fwrite for writing to a binary file and save to save data to a binary file, correct? But can I write heterogeneous data to a file? Yes, I can use the command readtable, and that will do something similar and writes the table T to what? To a file name. Now you need to make sure this table T is written with comma delimited. So you see here it says input what? It says input data specified as a table, and so you have to use the command table if you want to use that. You have to use the command table to create a table and define its what? Its rows, the values for the rows, and then anything else. And when you're done with the table, you provide the table and the file name, and it writes the data designed as table T to the file name, no problem. And this file could be, again, an Excel file, a text file, a .csv file, and so on and so forth. But again, you need to make sure whatever you create is what? Is a table. So if I want to do something with readtable, I have to create the table first. So look here. I try to create a table, and in this table I have rows, correct? I have rows, and if you want, I can have columns, and columns are created by basically these values that you provide in each one of these brackets and braces. Okay, so here I want to create a table, and this one I call it first person, then second person, and then third person. And then the name of them could be Jim, right? For the first person, and then for the second person be like Lily, and then maybe for the, I guess Lily has two L's, and then for the third person be like Megan, right? Now since they should be separated by semicolon, so it's a vertical column, and then I also have the values for the third variable, and this is the names and or the grades, and let's just use some grades here. Again, separated by that. So if you see here, I have created the table. This table has 3 variables, and it has 3 rows. And now I can write this whole table to a new file using the command write table, correct? So all you need to provide to write table is what? The table variable and then a name. So I can say this table T, and the name may be test5.text. Okay, write that for me. And now if I go to my files, there should be a test5, and this test5 should have that table written to it where the columns are separated by what? By comma. Okay, so that's one way to write to a text file, an Excel file, or anything. Now for Excel file, there is a specific command, xlsread and xlswrite, which I always prefer, and I'll show you how to work with that. But here is this read and write tables are powerful commands that you can write everything to and from different types of files, not just text file. Okay, but again, as I told you, you need to use the command table first for the writing. For the reading, no, but for the writing, first you create what? A table. Okay, you create a table, and you can see all sorts of examples for it if you want here. So you see here, I have a table, and this table has basically these variables, right? It has about what, 7 variables. Okay, you see, and then you can provide in this table the different rows. Okay, so that's the way to go about it. So you can clearly see that here too, how to create a table, how to create different columns or different variables, and how to create text file from these tables or Excel files. Now, as I told you in the past, there is this command fprintf, using which you can write what? Text to this command window, but you can also write it to a file. And this thing that you provide to it should not be the name of the file, it should be the ID of the file. So before you can use this, you have to get the ID of a file using the command what? Fopen. You have to get the ID using fopen, then provide a format, and then the variables. Okay, so here, as you can see, I want to provide some format, and then the format is this. X is written as 4.2 meters or 8.3 millimeters. Okay, and for that I provide the values in A1 or A2 and write them to this binary file. So to this text file. But let's find out what we can do here. Let's provide an example instead of just looking at the help. So here, let's say I have some variable a, and this a is 6 feet. Then I say writing format is equal to, I can jump % d feet. Okay, and this d, this %d should be replaced by the number 6. So this is the writing format. The variable a, or a if it's an array, the entries in a should come and replace what? This d, right? To make it a combined complicated text, and now that text can be written to a file. First, I have to open a file, whether it exists or I can ask it to be made for me. So I need what? I need an ID and I need a message, error message if it exists, and then say fopen. and then provide the name here. Now I can make it if you want. So I say maybe test number 6. Okay, that's the name of the file to open for me. Test.6, and maybe text, doesn't matter, it we'll find out. And then I want to open it for writing. Okay, there is no error message, the ID is more than 0, so the opening was successful. Now this guy is open for writing, and now I say fprintf to this ID number 3, and then what? I have to provide the format and then the data, correct? So I need this writing format, and then I need the data in A to come and sit in the place of this person D, and write the result of that to this FID. And then it returns a number here for you, and this positive number, we can look at it, what it means, 17. But for now, I say fclose or status equals fclose of FID. When my job is done, I make sure my file is closed. The status is 0, so means the closing was successful. Now you might say, what is this 17? So let's go and look. If we count the number of characters here, if I replace for D6, it's gonna be I can jump 6 feet. How many characters are in it? 1, 2, that's 3, 5, 6, 4, 10, 11. This is going to be 12, 13, and then 4 of them in feet, 17. So this number returned by this command is the number of characters written using fprintf. And now I can go and look at text 6. And you see, that's written over there. So you see fprintf acts very similar to fwrite. It needs an ID. What's the difference? The difference is it needs a format to use along with the variable. The good thing with fprintf is the file that it creates or it opens for writing is not going to be encoded binary. So I can really see and read the text I wrote to the file. While fwrite wrote it in a binary manner, I could not read anything when I open it. Okay, so in that aspect, fprintf is better. It writes everything as a text, not as numbers, but I rather work with fprintf than fwrite if I want to be able to open it and see it. If I don't care about it, then and I trust it, then I use fread to read the value from it in MATLAB, back in MATLAB, so now I can look at them. But I personally prefer fprintf, or even if possible, not possible, I prefer readtable. So these are different ways to communicate. As I told you, there is one other command or two other commands for dealing with Excel files directly. Okay, you could see that I could use read and write table, but I would rather work with this xlsread and xlswrite files. I always prefer them. They are very clear and you know what you're doing with them. So here I have this Excel file test1, and this test1 has two columns, X and Y. They are both defined in sheet 1, and X, the values for X are from A2, cell A2, which is here, all the way to cell what? A222. Y's are from B2 to what? B22. Okay, so how do I work with it? This is how you work with it. First of all, when you want to read something from the Excel file or write something to the Excel file, make sure the Excel file is what? Not open. Make sure it is closed. Then come here and use the command xlsread. If you want to read something, you say x equals xlsread of, provide the name of the file. The name is test1 dot, as you can see, xlsx. So that's the name of the file, Which sheet is it? The data are in sheet 1. And where was the data? It was from A2 all the way to A22. Read it and call it vector x. And it should do it as long as the file is not open. You see, it did it. Then go from B2 to B22 and call the data y. Did, and now you can say plot x versus y. Boom. Good. So I can easily write read data from the Excel file by providing the name, the sheet number, and the range of the cells in the Excel file. So xlsread. Now, can I write something to the XLS? Sure. So let's say I have a vector z, which is equal to, let's say, x times y. And now I want to write the values in z to the third column in sheet 1 of that Excel file. So now I use the command xlswrite. I provide the name again, which is test1.xlsx. I want to write them to sheet 1 again, and the range of the data will be from C2 to C22, right? Okay. Now what's missing here? I did not tell it what variable to write, so I have to tell it what variable to write. Of course, z. That's your second argument. What do you want to write? Z. Now let's do it. And now let's go and look at the Excel file. Yes? You see clearly this column is the product of those two columns. So I could clearly write whatever I want to the Excel file. Again, when I want to read and write to the Excel file and from Excel file, it should not be open. Now you might say, can I write a piece of text to the Excel file? Like you see here in the Excel file, I had x and y in positions A1 and B1. Can I write a z to this position C1, right? Can I do that? So all columns look similar. So we say, let's try it. I want to write z, character z, to the test1 in sheet 1, and the location for it is C1 to C1. Just location C1. Can I do that? Well, apparently it says yes. So pay attention. This is character z, this is the vector z. Well, let's find out. Yes. Okay, so you see I could easily add this column with text, with numbers and everything directly from MATLAB. So if you have data in an Excel file, you don't need to copy and paste the whole thing in MATLAB and define them as structures or something. You can easily read and write using these different types of commands. So hopefully this demo was useful to you, and I'm going to see you in future lectures. Thank you.